Hi guys! So today we're going to be looking at Chapter 3, Section 2, Complex Numbers. So before that, let's try out this review problem first. The question is asking you to solve for x to the power 2 plus 6 equaling to 5. So if I'm going to solve for x in this case, I'm going to start off with having x to the power 2 plus 6 equaling to 5. And I'm going to subtract 6 on both sides. When I do that, I'm left with x to the power of 2 equaling to negative 1. And from here, to get rid of that power of 2, I'm just going to square root on both sides of the equation. If I square root on both sides of the equation, I'm left with x equaling to square root of negative 1. Now, so far in section 1, we learned that having a square root of a negative number gives us no solution. But today what we're going to be looking at are complex numbers. A complex number that we're going to be looking at is called an imaginary number. Imaginary. And we're going to call it imaginary unit I. What I does is I replaces our square root of negative 1. And specifically, it has to be the number 1 that's being negative. If we have negative 1 being square rooted, I could replace that for I. So instead of getting negative 1 square root and then getting the answer no solution, what I could do instead is I could change my square root of negative 1 into just being I. So here x would equal to the imaginary number I. And that's what our goal is today, is to be looking at specifically these complex numbers where it's an imaginary number. So let's try out by looking at the properties of I. So properties of square rooting a negative number. The first property that we're going to look at is the following. If I have a square root of a negative number, and it could be any number, it could be negative 10, negative 100, negative 5, negative 25, no matter what, we can take out this negative sign by using the imaginary number I. And then whatever is left over in the square root will just stay in the square root. So for example, let's say that I have the square root of negative 3. I could split this up and expand it by writing down negative 1 times 3. Negative 1 times 3, this does equal to still square root of negative 3. So it's still equal to it and still got the same answer. But now what I could do is I can split up my square root into two parts. I could split it up as square root of negative 1 times the square root of positive 3. And then from here, I could solve out the square root of negative 1. Square root of negative 1, that equals to I. Just like we said earlier in our rule over here, that whenever you have a square root of negative 1, that turns into I. So in our property, we're left with I times the square root of 3. So instead of going through all of these steps right here, if I were to have another example, let's say you have here square root of negative 11. All I have to do is write down I square root of positive 11. And that would be my simplified version. Let's check out another property. Another property that we have here is I square root of r to the power of 2. So before we even get to this property, let's look at I first. We said that I is equal to the square root of -1. If I were to square both of them, if I were to square this square root of -1 and I were to square this I would be I to the power of 2. And over here, if I were to look at the square root or the square of the square root of -1, this would just be left as -1. So we can say here that if I is to the power of 2, that has to equal to -1. So over here, if I have I times the square root of r to the power 2, I could distribute that to the power of 2 to both the I and to the square root of r. And let me put those parentheses in there. Square root of r squared. If I do that, I get here -1 because we already said that I squared, it has to equal to -1, multiplying with square root of the squared of the square root of r, that just equals to r. So we get here -r. So if I were to write an example, let's say that our example here is going to be I times the square root of 3 to the power of 2. In this case, we would get, and instead of doing all of these steps, I could just make my +3 that was inside the square into a -3 and take out that square root. Okay. So another definition that we're going to be looking at is specifically complex numbers. So a complex number is written in standard form and is a number where you have a plus bi, where a is a real number. Normally we'll have types of questions where we have equality of two complex numbers. We're going to be asked to find the values of x and y that satisfies the equation. And let's say you have the equation here, 2x minus 7i and 10 plus 9i. You can think of I as if they were variables or similar to like terms. So what I want to do is if I want to solve for x value and the y value here, I'm going to first start off by thinking of I as a like term. So anything that has an I next to it, we can say are like terms with each other. So right here, -7i and yi are just like terms. I can combine them together. So on the side, I'll write here -7i equaling to yi. And then the terms that don't have I, such as the 10 and the 2x, I'll make their own equation as well. We'll have 2x is equal to +10. From here, I can solve for my value of x and my value for y. So right here, I could divide 2 on both sides. If I do that, I get x is equal to 5. On the other side, I could divide I on both sides because that would give me my y value. So if I do that, I get left with -7 equaling to y. And so that would be my final answers. I found out what my x is and what my y is. And if you were to check it, you would see that you would notice that they are equal to each other. So let's say that you want to check your answer. Right here, we have 2x minus 7i equaling to 10 plus yi. If I plugged in the 5 into the x and the -7 into the y, we would get here 2 times 5 minus 7i equaling to 10 plus -7i. When I solve this, I get 10 minus 7i equals to 10 minus 7i. So based off of this, you can tell that if I were to add 7i to both sides, that would get rid of my 7i's, and I would be left with 10 equaling to 10. So we know that our answers, our solutions for x and y were correct because of the fact that when we wrote down the statement, substituted the x and the y, we were able to get equal solutions. Cool. So let's look at the last one. Right here, we're going to be asked to add and subtract complex numbers where we have I values in them. And again, whenever I have the value of I, we can think of it as a variable, such as like y or x in a sense. So just like any variable, I only want to combine like terms. So over here on this equation, if I have here a minus I plus 5 plus 4i, all I want to do is just combine the like terms. So we get here 8 plus 5, negative I plus 4i. 8 plus 5, that equals to 13. Negative I plus 4i, that equals to positive 3i. And again, we can't combine these two together because there's not an I next to the 13. So we'll just leave it as 13 plus 3i. For the other equation, start off first by distributing that negative sign to both terms. We get here 7 minus 6i, negative 3 plus 6i. So again, I'm going to combine the like terms together. Negative 6i goes with the positive 6i. That just turns into 0, so I can cancel these out. Now I'd be left with 7 minus 3, which equals to 4. So this would be plus 0. That just gives us 4 as our answer. Okay, so hopefully this helps. Good luck.